Failure of engineering material is almost always undesirable event. Even the behavior of material is known, prevention of failure is difficult to guarantee. And in industry, failure may cause danger to human life and also economic losses. So from this present discussion, I hope you're gonna get good information about fracture. So fracture in the sense I can say whenever the object is subjected to load, it breaks into two or more pieces. Okay. Here it is defined. Fracture is defined as failure of material under load by breaking into two or more pieces. Okay. Now let me move to the types of fracture. For engineering material, two modes of failure is possible. First one I can say as brittle fracture and second one is a ductile fracture. So in order to understand ductile fracture and brittle fracture, here I have shown you two images. Okay, so these images I got from the experimental work. Okay, so here I have considered two cylindrical rod. One is here and one is here. Okay, I have considered two cylindrical rod and I have applied a tensile load to both the rods. I have applied the tensile load to both the rods. At the end of the experiment, I found that so in the first case it is observed such manner, and in the second case it is observed such manner. You can see the difference here. The failure is happened just breaking into two pieces just by crack. Okay, just by crack. But if you see here, it is broken into two pieces. It's well. Okay, but when you compare with the first one, here you can see the reduction in size. Am I right? You can see the reduction in size, but here just a crack. But here you can see reduction in size. Afterwards only it is broken into pieces. So I can name the first case as a brittle fracture and second case as a ductile fracture. This is happening because of brittle fracture. This is happening because of ductile fracture. And in furthermore detail, I can say this brittle fracture is happening in the material without any appreciable plastic deformation. It is happening, the material takes place in the material by rapid crack propagation. Okay, so here you can see the cracks, right? Because of crack only, it's broken into two pieces, right? So, and also one more observation we can get from this experimental work. That means it is determined the direction of the crack motion. That means here is the crack. This direction of the crack is very nearly perpendicular to the direction of applied tensile stress. Okay. First of all, here we will apply the tensile load. Am I right? It is been observed that the crack motion will be very nearly perpendicular to the tensile load applied to this material. Okay, and then on the other hand, I can say the ductile fracture is happening in the material with considerable amount of plastic deformation. Okay, with considerable amount of plastic deformation. That's why you can see there is a reduction in area. Correct, there is a reduction in area. Okay, and also the broken pieces. Okay, these are the broken pieces. If you just fit the broken pieces, or if you join those broken pieces, you cannot regain the original position. But when we come to the brittle fracture material, okay, if you connect those pieces, you can regain the same shape as a initial one, right? Can you able to imagine? Can you able to imagine just you are connecting this rod as well, you are connecting this rod. You can get here the original shape, but here you cannot get the original shape. This is because of the plastic deformation. It failed with plastic deformation, it failed without any plastic deformation. That's the reason the regaining of shape is happening in the brittle fracture material, but it's not in the ductile fracture. Okay, let me move to the next one. In favor of understanding the stress strain curve of brittle fracture and ductile fracture, I want you to remember the result which we got from the tensile test. Okay, we obtained that when the load is applied initially, the material will be deformed elastically, okay, up to the yield stress. When it is crossing beyond the yield stress, what happens? The material will deform plastically, and at last it will be fractured. Just look at this graph. Actually, this graph is done for brittle fracture, and if you look into this stress strain diagram, I can say the curve is tracing the proportional limit, and it is increasing furthermore to yield stress, and with very less increment it breaks, right? And if you move to the ductile fracture, you can see it is first of all tracing the proportional limit, and next it is going to the yield stress. Again it is capturing the ultimate stress, and then it is fractured, right? So but in this case evidently you can see it is failed. That means brittle fracture is occurs with what, no appreciable plastic deformation. Okay, but here you can see this ductile fracture is happening with what, plastic deformation, right? When we compare this ductile fracture and brittle fracture, you can see evidently from the graph the area obtained by the brittle fracture is very less when compared with the ductile fracture. Am I right? So from this it is determined in brittle material energy absorption is very low. The area covered is very less, so it has been determined in brittle material the energy absorption is low. Okay, and in the ductile material energy absorption is very high, right? The area covered is very high, so the energy absorption is determined as very high. So from this we can conclude the toughness of the material is very high in ductile material than brittle. Next, when I describe about this ductile fracture, I said it happens in the material with plastic deformation, right? Yes. So now let me discuss steps in ductile fracture. Okay, here you can see the image of steps in ductile fracture. So first actually I consider the cylindrical rod, and I applied the tensile load. Okay, so initially you can look at this A image. Okay, what happening when the tensile test is increased, I can say it is going beyond the ultimate stress. Okay, it is going beyond the ultimate stress. What is happening? You can see evidently from this image the necking will be formed. Okay, when it is increased further beyond ultimate stress, you can see the formation of necking. Okay, again if it is continued of loading with furthermore increment. Okay, so what happens? You can look at the B image. There will be a formation of micro voids. There will be a formation of micro voids. Okay, and then if it is increased, the same load is upon increasing, what happens? This formed micro voids will pave way to form the crack, right? Again the condition is increased. Okay, the load is increased. You can see the crack propagation. That means this crack will be grown. You can see the crack propagation by the shear deformation. Okay, there will be shear deformation, right? There will be a shear deformation at this extent, right? So it is experimentally proved that this shear deformation happens with 45 degree angle, right? And again furthermore increment of load, you can see evidently the broken piece of the material. Okay, so here if we observe clearly, I can say it will give the observation just one piece as a cup shape, one piece as a cup shape, and another piece as a cone shape. and it is being said that this ductile fracture result with cup and cone fracture. So by this we can end up the session. Thank you.